Welcome to Science Easy Tech channel. In this video, we are going to discuss about reliability in nursing research and statistics. Already I have posted a video on validity. If you have not watched it, I have given the link in description box, suggested end card, or also you can watch our channel playlist Bsc Nursing 4th year research and statistics for validity related video. Or you can browse in YouTube as validity in nursing research in Science Easy Tech channel, so that you can directly get that page opened. So before moving on to the topic, if you are new to Science Easy Tech channel, just take a moment to subscribe our channel and also to press the notification bell icon in order to get connected with our latest updates. Let's move on to the topic. What is reliability? Reliability, the definition is, it is the degree of consistency with which an instrument measures the attribute for which it is designed to measure. So reliability is the degree of consistency with which an instrument measures the attribute for which it is designed to measure. Reliability is defined as the ability of an instrument to create reproducible results. Reliability is defined as the ability of an instrument to create reproducible results. So this is the definition for reliability. So let me explain what is reliability. So reliability is nothing but, here instrument means the tool what you are using for data collection. Either it can be a biophysiological instrument like BP apparatus, thermometer, like that and all, or it can be a questionnaire, or it can be a rating scale, or it can be a checklist. So whatever you are using in order to collect the data collection tool is called as an instrument. So how much it is reliable, so how much it is consistent, the tool or the instrument what you are using for measuring whether it is reliable means whether it is consistent. For example, you are telling Sachin's batting is consistent. That means what? In most of the things he is having his batting average score is 80, more than 80, like that means we can tell he is a reliable and consistent player. Okay. Suppose in one game if he is getting 100, in other game he is getting only 10 runs, another game he is getting 20. So you cannot tell he is a consistent player. At least he should for more matches what he has performed, his batting average score is more than 75, more than 80, like that means he is a consistent player, like that you can tell. So how you can find this consistency? By means of reliability only. So reliability is defined as the ability of an instrument to create reproducible results. What is this reproducible results means? For example, suppose if a sphygmomanometer you are using to check the BP. So for an adult at different types on the same day, if you are going to use, suppose now I am checking BP. Okay, now it is showing 120 by 80. After half an hour, if I am checking in the same apparatus also, if it is showing 120 by 80, and after half an hour I am telling if it is showing 120 by 80, then you can tell that the instrument what you have used for measuring this blood pressure is reliable. Okay, is reliable. So this is what with regard to what? With regard to the instrument what you have taken for checking the BP is consistent and it is reliable because it is giving the same results. When you will tell it is not reliable, suppose now we are checking, so 120 by 80 is there. So after half an hour if you are checking, it is shooting up to 180 by 160 without any pathology for the patient, and another half an hour again it is coming to 60 or 40 mm of Hg, means it is not reliable. There is some problem with the instrument. Okay, so that is what is called as reliability. An example, a sphygmomanometer gives the same reading for the same subject at different time interval is considered reliable. Next we will see the elements of reliability. There are three important elements of reliability. What are they? Stability, equivalence, then internal consistency. Stability, equivalence and internal consistency. Let's see one by one. Okay. What is the stability? Stability means research instrument provide same results when it is used consecutively for 2 or more times. Okay, stability means what research instrument means, what I have told. It can either be a questionnaire or a rating scale or a checklist or a biophysiological tool or instrument. So when you are going to use that data collection instrument or tool, it will be producing the same results when it is used consecutively for 2 or more times. Suppose now if I am giving one test questionnaire to you, okay, so you will be answering it. Next, after half an hour or after 2 days, if I am going to give that same questionnaire also, the results may be more or less same. Okay, the results may be more or less same. So that's why this stability, the reliability for testing stability, it is also known as test retest method. Suppose today the questionnaire I am giving, tomorrow if I am going to give the same question also, the results are going to be more or less same. Okay, so the test is administered twice at 2 different points of time. Either it can be half an hour interval, 2 hours duration, or 2 days duration, or 1 week duration. It depends. Okay, so the test is administered twice at 2 different points of time. Next, it is used for questionnaire. It is used for questionnaire, observation checklist, observation rating scale, and physiological measurement tools. So where and all the stability test retest method is used, it is used for instruments like questionnaire, observation checklist, observation rating scale, and physiological measurement tools like BP apparatus, pulse oximetry, like that and all. You have so many biophysiological methods, no? So that comes here. Okay. Next is statistical calculation of stability. What is this statistical calculation of stability? So I am telling test retest method. So how you will be comparing the results? By using statistical methods. So what statistics will be best suit for testing the reliability? Yes, to compare the results, the best method is already we have learned to compare or correlate. That is Carl Pearson coefficient of correlation. Already I have posted a video on Carl Pearson coefficient of correlation. You can watch our channel playlist, or I will be giving the link in description box also. You can go and see it. Okay, so here the administration of research instrument to a sample of subjects on 2 different occasions. For example, today I am giving a questionnaire to 4th year Bsc Nursing students. Okay, after 2 days the same questionnaire I am giving. So today's method is test. After that 2 days I am giving you, that is called as retest. Okay, next today's score and 2 days after I am conducting no retest, that scores I am comparing or I am correlating by means of what method? By using Pearson's correlation of coefficient method formula. So when you are getting R, if R value is 0.7, it indicates acceptable level of correlation. If R value is 1, it is perfect correlation. If R value is 0, there is no correlation. If R value is 8 or 9 also, it is high positive correlation. Okay, so if it is 0.7, it is acceptable level of correlation. 0.8 or 0.9, high reliability. Okay, +1 indicates perfect reliability, whereas 0 indicates no reliability. So what is the formula? So you have so many formulas. The Carl Pearson correlation coefficient formula, R is equal to sigma xy minus sigma x into sigma y divided by n divided by square root of sigma x square minus sigma x whole square divided by n into sigma y square minus sigma y whole square divided by n. So this is the formula. In MSc level, if you are writing reliability, definitely you have to use this formula. Otherwise, you can write that statistical calculation for stability was done by Carl Pearson coefficient of correlation formula, and only these 3 points you can write. Okay, no need of listing the formula. If you are writing the formula, well and good. Suppose if you are not able to remember the formula, instead of writing wrong formula, just leave it off. Okay, so R is equal to sigma xy minus sigma x into sigma y divided by n divided by square root of sigma x square minus sigma x whole square divided by n into sigma y square minus sigma y whole square divided by n. Okay, so this is for the formula for calculating stability. So the result what you are getting R, if R is 0.7, it indicates acceptable level of reliability, plus 1 perfect reliability, 0.8 or 0.9 high reliability, 0 no reliability. Okay. So first thing is stability. Okay, 3 elements. First thing is stability, which is otherwise called as test retest method. So that is completed. Next we will see internal consistency method. It is also called homogeneity of the research instrument. Homo means same. Homogeneity means same. The research instrument what you are going to formulate. Suppose if you are going to formulate a tool to assess the knowledge on hypertension. So your question should be based on hypertension. If suppose 20 questions you have formulated, all the 20 questions should be related to hypertension. Otherwise, if suppose 10 questions you have formulated on hypertension and 10 questions you have formulated on epilepsy, then it is not going to have any interrelation. That's why all the questions, what topic you have taken, whether all the questions are coming into one line. Okay, whether hypertension means whether definition, incidence, whether risk factors, causes, pathophysiology and home management, diagnostic findings, management, then prevention, home care, like that in a sequence, whether it is going or not, you will be assessing by means of internal consistency. So this is otherwise a research tool is considered to be internally consistent if all the subparts means each question is a subpart, or each statement in a Likert scale, like that attitude scale means each subpart is a so each statement is a subpart. So a research tool is considered to be internally consistent if all the subparts of the tool are measuring the same characteristics or phenomena. So this test is otherwise called as this approach is otherwise called as, like in stability we have told no test retest method. Internal consistency we are telling it as what? Split off technique. What is this split off? Suppose if there are 20 questionnaire, you have formulated a questionnaire. 20 questions are there in your questionnaire, in your research tool. So this 20 questions, odd number questions and all 1, 3, 5, 7, 9, 11. Odd number means, see 20 questions you have given numbers now 1, 2, 3, 4 like that up to 20 you have given. So odd number questions and all you take one side. Okay, even number questions and all you take one side. Okay, that is split off technique. Or sometimes you can take first 10 questions one side and second 10 questions from 11 to 20 one group. Either you can do in this method or first method I have told no, odd number group, even number group. So odd number questions and all in one side you split it, even number questions and all in one side you split it. If it is difficult, or you can take first 10 questions in one group, second 10 questions in one group. Okay, then what you can do, this is for questionnaire. Similarly for Likert scales also statement. Suppose you have formulated 20 statements, same thing, only first statement, third statement, fifth statement, like that you can do it. Okay, so what you have to do, you have divided the items into two equal parts through grouping either in odd number questions or even number questions, or questions of first of items and questions of second of items. So like that you have divided it. So next what you have to do, administer these two subparts of the tools simultaneously, score them independently. Okay, so what you have to do, you have to administer the first part questions you have to give and the second part questions you have to give to one group. Then what you have to do, you have to compare the results. So when you are comparing the results, you should use Cole-Pearson coefficient formula or Cronbach's alpha formula. So administer two parts of the tool simultaneously, score them independently and compute correlation coefficient in these two separate scores by using formula. Okay, so first 10 questions you will be administering to one group and again the second 10 questions you will be administering. Okay, so then what you will be doing, so you have to compare the two groups results. Okay, you have to compare the two groups results. R is equal to sigma x minus x bar into y minus y bar divided by square root of sigma x minus x bar whole square into sigma y minus y whole square. Okay, so this is also what called Pearson coefficient of correlation, another formula. See, R is equal to sigma x minus x bar into y minus y bar divided by square root of sigma x minus x bar whole square into sigma y minus y bar whole square. So here also same thing only. If R is 1, perfect correlation or perfect reliability. If R is 0.7, acceptable level of reliability. If R is 0.8 or 0.9, high level of reliability. If R is 0, no level of reliability. Or you can use one more formula. So they will ask for testing a inter-rater method. Okay, for testing a split off technique, not inter-rater method. It is split off technique. So split off technique, what you will be seeing, internal consistency you will be seeing. So that is measured by means of Cronbach's alpha. Here the formula is R is equal to kth sample, that is k divided by k minus 1 into 1 minus sigma standard deviation of a square divided by standard deviation y square. Okay. So in MSc level you have to write all these formulas and all. In BSc level just mention the names by Carl Pearson coefficient of correlation method as well as Cronbach's alpha method. You will be calculating the split off technique to find out the internal consistency of reliability. Next, moving on to the third element, that is equivalence. Equivalence. This aspect of reliability is also known as inter-rater or inter-observer reliability. So stability is otherwise called as test-retest method. Then in internal consistency, what we have seen, split off technique. In equivalence, this is otherwise known as inter-rater or inter-observer reliability. This includes when two different observers were observing a single phenomena simultaneously and independently. For example, let me tell, in practical examinations, okay. So internal examiner and external examiner, you are doing a procedure. At the same time, you are observed by an internal examiner as well as external examiner. Okay, and they will be rating yourself. Okay, what procedure you have done. Suppose if you have done a bed bath, so internal examiner has observed you and external examiner has observed you, and they are having some criteria to rate you and how they are rating it. Okay, so that is an example for inter-rater or inter-observer reliability. So when two different observers were observing a single phenomena simultaneously and independently. For example, a rating scale is developed to assess the cleanliness of bone marrow transplantation unit. So a rating scale you have developed, in that you are having some 20 points or 30 points to assess the cleanliness of the bone marrow transplantation unit. Here two observers can rate the rating scale by observing the bone marrow transplantation units simultaneously but independently. So here two observers will be going auditing and all they are doing. That time they are doing two observers and they are giving their rating. Okay, in inspection also the two inspectors are coming and they are giving rating, like that. Here the two observers, they are giving the rating for this simultaneously. They are rating it, but independently they are rating it. So the same phenomena they will be observing and they will be rating it. So suppose if you are going to give a questionnaire, okay, or if they are going to give a checklist. Okay, one person how he or she is rating. Similarly, other person how he or she is rating. So whether there is consistency, whether there is correlation, you will be comparing the person's A observation with that of person's B observation rating. Then you will be comparing, again you will be comparing or correlating this thing. So here how you will be calculating our number of agreements, in what aspects and all, both have given the same opinion, divided by number of agreements plus number of disagreements. All the points may not be same. If one person is telling, suppose if there are 20 points, for example some 15 points both are accepting it, and 5 points both are not accepting it. So what you will be writing, number of agreements, okay, that is 15 divided by number of agreements 15 plus number of disagreements 5. Okay, 5 aspects they are not agreeing. So that based on this you will be calculating the results what will be coming now, so that you will be calculating that value is called as R. In R, what you have to see, same thing only, R is 1, perfect positive correlation. If R is 0.8 or 9, highly reliability. Okay, if R is 0, no reliability. If R is 0.7, acceptable level of reliability. Same thing only. Or it can be 0.5, 0.3, that and all shows very less reliability. And suppose if it goes in negative direction, it is minus reliability. Okay, negative correlation. So what are the factors affecting reliability? There are some factors which will be affecting the reliability: length of the instrument, random error, training of observer, number of observations, the time allotted, language of items in the scale or tool what you are using, group homogeneity, that is group with same characteristics, duration of the scale, how long you are going to administer it, objectivity. Objectivity means you should not have any bias or personal judgment, opinion and all. Extreme climatic conditions, the environment where you are administering the tool. Then the instruction to be given to the participants, what instruction you are going to give for the participants. Then difficulty index level, that is understanding level, like that. Okay, so the length of the instrument and random errors, sometimes errors can occur. Then when you are selecting the samples also, training of the observer should be well trained in administering the tool. Number of observations, how many samples you are going to observe, then and how many times you are going to observe, the time of administration of the instrument or tool, language of items, whether it is in own language, whether they are accepting the language, like that. Group homogeneity, that is the group should have same characteristics, that is homogeneity means same. Duration of the scale, how long you are going to administer. Objectivity, extreme climate conditions, instruction for participants and difficult index scale. So this gives an in-depth thing with regard to reliability. Hope this video is clear for you all. This video is useful for Bsc Nursing students, Msc Nursing students and post-basic Bsc Nursing students. You can watch our channel playlist for more nursing research and statistic related videos. I have given most of the statistics and the nursing research playlist in the description box also. You can watch it. Kindly support to Science Easy Tech channel. Thank you friends. If you like my video, please give a thumbs up, share and subscribe to Science Easy Tech channel.